If we start with a 4-bar mechanism like this and replace the revolute pair over here by a sliding pair, we would get a different mechanism. Let us first do it in a schematic diagram. So this is the 4-bar we have, and we are going to replace this revolute pair with a sliding pair. So this is the schematic of our new mechanism. A fixed link is here. On one side it has a fully rotating pin giving a crank, while on the other side it has a link that slides relative to it, and therefore this will be called as a slider crank mechanism. We can consider either the crank or the slider as the input link, because slider crank transforms reciprocating motion into rotary motion, as in case of IC engine, or the rotary motion into reciprocating motion, as in the case of a reciprocating pump or compressor. In its physical form, it can be represented like this. Link AB, shown over here, is the crank, which can rotate completely like this, and as it does so, the slider moves back and forth. The link that connects the crank and the slider is called the coupler. The two extreme positions of the slider are called TDC, top dead center, and BDC, the bottom dead center. Slider crank is used in internal combustion engines and also in reciprocating pumps and compressors. In that case, the slider is a piston that is reciprocating in a cylinder. Real-life engines often have several slider cranks arranged in line like this, forming an inline engine. They can also be arranged in a radial manner like this, so that all three or more of them can drive a single crank. This is called a radial engine. Let us follow this link to see a radial engine in action. So this is how a radial engine looks in 3D. Of course, typically it would have more cylinders than just 3. And let's set it in motion. The cylinders are firing in a cyclic order, and they are all driving a single common crankshaft. This all may look very complicated, but we must remember that at the heart of it all there is a simple slider crank mechanism.